All right, well, thank you all for coming. Um, we've presented a little bit on the Inlet Atlas before in terms of some of the data and data products that are going into the Atlas. So I'm briefly going to go over that, and then I'm going to hand it over to Charlene to talk about the actual Atlas itself. Next slide, please. So just a tiny bit of background on coastal inlets. So they're a common feature on sandy barrier coasts. They generally have really complex, rapidly changing geomorphology because they're influenced by waves, currents, storms, human engineering, a variety of things on a variety of time scales. So they tend to really quickly migrate, scour, infill, and they can also be a big factor in regional sediment variability. And this figure on the right is just kind of a diagram of a general coastal inlet with some of these various ramps, channels, lobes, and platform features. Next slide, please. So the USACE maintains nearly 200 coastal inlets, both tidal and non-tidal, so Great Lakes. They provide millions of jobs and trillions of dollars in value to the nation through, commerce, military access, recreation, ecosystem services, etc. But to maintain safe navigation in channels, we dredge near over 200 million cubic yards a year at a cost of nearly $2 billion. That's not inlet specific, that's everything, but inlets are a pretty good portion of that. And this is just an example, kind of infamous picture of the severe shoaling in the navigation channel at Manasquan Inlet, New Jersey, where this shoal will grow to fill almost half the width of the channel and severely impacts navigation and Coast Guard operations. Next slide, please. So to improve O&M and RSM practices, CIRP maintains the U.S. Coastal Inlet Atlas, which is currently an ArcGIS online database and map with scalar information about inlets, the length of the inlet, authorized depth, tidal prism, etc. But it currently lacks ready-made bathymetric or geomorphometric data analysis products, and it has to be manually updated and maintained at this point. So great information, but one of our current efforts is to update the Atlas. Next slide, please. So we're going to expand the Atlas to include geospatial information like bathymetric data sets and the results of 4 geomorphometric analysis methods. I've presented on some of these before, but if you have questions about that, reach out to me or to the team. So I'm kind of going to gloss through those really quickly, and then Charlene is going to talk about the actual changes to the architecture of the Atlas. Next slide, please. So we've initially chosen 13 inlets to be our, kind of initial study sites. You can see them here on the map. There's a variety of wave climates, tidal ranges, inlet morphologies, and both natural and engineered inlets. Next slide, please. So just really quick overview of the data that's going into the Atlas. We're taking topobathymetric LiDAR data from the National Coastal Mapping Program, and if necessary, supplementing it with district hydrographic data, and then doing some processing, QA/QC, basically ending up with a time stack of high-resolution bathymetry for the inlet. Next slide, please. And then we're taking those bathymetry rasters and we're running these 4 geomorphometric analysis methods on them. I have them kind of highlighted in red on our little workflow. Again, we don't quite have time to go into detail on those, so I would point you to our recently published tech note, or you can reach out to me and I'd be happy to talk about it. Next slide, please. These are just some of the example data products that are going into the Atlas, mostly either like raster-based geomorphic analysis data products and or graphical data products. Next slide, please. And just really quickly, some potential management applications for especially district users for what will finally be in the atlas when it's ready is to maybe identify sediment borrow and placement areas, track shoal migration to improve mapping efforts, add information to hydrodynamic and sediment transport models, estimate post-dredge recharge rates, aid in the siting and scoping stages of coastal engineering products, or inclusion into other ready-made USACE tools eventually, such as the sediment budget analysis system. Next slide, please. And with that, I'll hand it over to Charlene.
Thanks, Katie. So as Katie mentioned, we have this existing coastal inlets of the U.S. Web map, which is really based on a feature layer that resides in CHL's ArcGIS online subscription. This database actually does consume a minor amount of Esri, what are known as Esri credits. And those credits will be charged, for every year that the database is sort of sitting in that ArcGIS online, subscription. And it is, as Katie mentioned, that one primary point feature class with all the attributes, only some of which are shown here on the tables. And that's kind of that scalar information that Katie was referenced. And one of the biggest things is that this data is effectively disconnected from any authoritative data source. And in order, to update this information, it's literally somebody kind of downloading that database from ArcGIS, online, doing the manual updates, and then like resubmitting that database to ArcGIS online. So it's just updating is just not as efficient as it could be. And then what this actually ends up resulting in is several versions of this geodatabase kind of existing across various Microsoft Teams sites, Corps of Engineer, machines, and questions come up like which source is authoritative, which source is current, which source, is the most recent. So the data can quickly kind of come, out of its currency. So with the new Inlet Atlas, or sort of the vision for Inlet Atlas 2.0, if you will, we wanted to basically modernize that data storage and dissemination architecture to promote the efficient discovery, access, use, and maintenance of these R&D products for the field practitioners, researchers, and others that have an interest in this type of information. So with that, we've largely focused on sort of just the data storage itself. So going from a hosted sort of feature layer in ArcGIS Online subscription to an enterprise geodatabase that's actually hosted on Corps of Engineer hardware on the RDE network. And as I'll explain, we've done that in partnership with other Corps of Engineer efforts. I also wanted to kind of pivot from sort of one primary point feature class that rules it all to a series of feature classes, business tables, relationship classes, and metadata that can kind of separate out the different types of data, and so that we could then leverage those different database things like relationship classes to link the data sets together and do it in a way that complies with current mandates for geospatial data in the Corps of Engineers. This could then be considered that authoritative source of data for the inlet information that's easier to update, and then because we're publishing the data set as, web services and applications, any changes we make to data in the geodatabase would sort of stay in sync. The web services and applications would stay in sync with the data that's in the geodatabase. And then finally, with these enterprise geodatabases, there's regular scheduled, backup routines that occur by the geodatabase system administrator. And so, as I mentioned, this our enterprise architecture was stood up with support by partnering with Mike Forte out at the FRF. So he has supported this architecture for the Corps of Engineer CorCam project for a long time now, and recently migrated that architecture over to ArcGIS Enterprise 11.3. As I mentioned, this all sits on the Research and Development Network at ERDIC, and there he has a Postgres geodatabase that's paired with the ArcGIS Enterprise 11.3 portal and server. In terms of sort of the geodatabase, the Postgres, portion of itself, we have implemented all of our feature classes and tables using the SDS FIE data standards, which I'll touch upon, just briefly in a minute here, but that's going to be all the vector and raster data sets that are needed to fully realize this next, this Inlet Atlas 2.0. The different tabular data or business tables that house, much of our metadata and related data. And then those relationship classes that I mentioned, we'll elaborate on those too as well, because those are really what are the drivers of kind of the connections between, say, the geospatial and the tabular data, and not just the data within the database, but also data sort of that exists outside in other enterprise databases within the Corps of Engineers. And then we also took the opportunity for the raster products that Katie had mentioned to compile those into a spatiotemporal access catalogs, as those are becoming more and more used, particularly in the research community. So for that, we're also leveraging the CHL Threads server with some support from Mitch. And so to touch upon SDSFIE, if you work with geospatial data, particularly in districts, you will probably have familiarity with this, but in case you don't, SDSFIE stands for the Spatial Data Standards for Facilities, Infrastructure, and Environment. What it is a family of standards and data models that promote findable, accessible, interoperable, and reusable data, so FAIR data. That family of standards includes standards for vector and raster geospatial data, how data quality is assessed and specified, and as well as standards specific for geospatial metadata. And the mandate for this comes from the Department of Defense Instruction 8130.01, Installation Geospatial Information and Services. And so its applicability is kind of in that installations kind of community, but it also does apply to civil works geospatial data as well. So I think it's important, like where possible, to try to comply with these standards. There is a governance group that sort of sits over SDSFIE. Most of those folks, at least in the Corps, sit at the Army Geospatial Center, but they provide regular training on SDSFIE standards and opportunities to contribute to that standards development process. There's some links there on kind of the use and the governance, and of course their website is actually really good. The website there's a number of tools where you can view the different sort of data models that are available, and then they have a model builder that you can kind of use if you kind of just need like a little subset of a particular model. And then of course they have a number of ArcGIS toolboxes to support the implementation of these standards as well. And so what we're looking at kind of on a little inset graphic is just the Corps of Engineers headquarters models that are available for anyone's use. Getting further into sort of what this actually, looks like and how it might apply to, say, this Inlets Atlas 2.0 project. So here from the SDSFIE model viewer, we are looking at one of the available feature classes known as project reference point. And this has a definition of a location or area delineating a specific project expressed in point form. This is the version of the entity that's expressed using the point geometry. So in other words, instead of sharing a database that has our inlets as points that are just called like inlet location, we are now going to call these project reference point in our enterprise geodatabase. And anyone that has a project, location in the Corps of Engineers is also going to put their project locations in that same feature class known as project reference point, so that everybody will have an understanding of what that means. And with this feature class comes a host of standard attributes that can be used to further describe, say, those project locations, and these are the attributes here, that we have here. So, there's some text. There's some fields that are probably used more frequently, say, than others, such as like a feature name or like a feature description. Certainly, the district codes, and project types. But these fields also do have many of our identifiers that we can use, unique identifiers that we can use to kind of link data sets between one another. And so this is sort of the set. This is like the standard for attribution for this particular, feature class. And if you start adding additional attributes, you're now violating SDSFIE data standards. So what we do is we expand upon this. And so with these SDFIE sort of models, you can actually generate a physical model. So we've gone through and identified those feature classes that we need to support the Inlet Atlas 2.0, and we have downloaded sort of what's known as a physical data model, or like a geodatabase template, using the SDSFIE model builder tool. And so then kind of getting that physical data model into our enterprise geodatabase, the first thing that we did was created a Coastal Inlets Research Program geodatabase instance. With the support of Mike Forte, we then we specified all of our geodatabase users and what their roles would be. And the roles really determine who has the authority to view data sets, to edit data sets, whether you're inserting, updating, or deleting a data set, and or creating data sets in the geodatabase. So there are a number of controls that you can place on your data to ensure its fidelity. And then we use the SDSFIE tool that's called Generate Geodatabase from PDM, or physical data model, to basically take that physical data model that we downloaded from the SDSFIE website and generate all of the feature classes that we would need in this geodatabase for Inlet Atlas 2.0. Those feature classes are kind of in the graphic there, underneath that change privileges geoprocessing tool. So we have our our project reference areas and points. We've got like a footprint feature class for our raster data products, and then thinking about potential for the future, there's a shoal feature we might be able to leverage, and then for some of the more advanced products, chronostratigraphic mapping, for example, we might leverage those transect feature classes. So we did a kind of a thorough look through the data models, kind of trying to pull out models that would apply to some of our Inlet Atlas 2.0, mostly vector and tabular data sets. And so for the raster data products, leveraging the SDSFIE raster standard, which is really just GeoTIFF. So the files as they exist coming out of our analysis workflows are actually already SDSFIE compliant. So really this SDSFIE compliance really applied mostly to our vector and tabular data. And so now that we've got kind of our geodatabase sort of initialized and populated with template, feature classes, we had to think long and hard about how we're going to actually link this, all together, thinking that these would be, this information would be provided as web services, viewable in web maps and web apps. And so we had to kind of think through the exercises of what we would expect the user experience to be in a web map or a dashboard, just so that we had all the attribution that we would need to support filters and queries of this information, and then also kind of support the linking of kind of information to the actual vector features themselves. So we created a number of relationship classes that we use to effectively extend the attribution on those SDSFIE feature classes. And so kind of in our UML diagram, here we've got that project, reference point there on the top, in blue. Again, that's their sort of inlet locations for the different projects, that we've run these geomorphic analysis tools on. And then we're linking that to sort of that project reference point info table is where we sort of extend the attributes with a relationship class. So the vector data set has like a primary key, that's that project reference IDPK, and that links to the foreign key that we store in that project reference point info table. And it works very similarly for the raster data sets as well. So we've got kind of that raster, footprint geometry. That's a vector, data set, has not a whole bunch of attributes there, right? But we, of course, want more attributes on that. So we created another business table called raster footprint info, and likewise populated with the necessary primary and foreign keys to enable those relationship classes. And so we have a number of these relationship classes. They can either kind of be like a one-to-one. So like every inlet location will link to a column in that inlet information table, and or like a one-to-many. So you might have an inlet location that is then going to link to a number of product bathymetric, say, product footprints, for each like moment in time that was analyzed. And again, these are all globally unique identifiers that are actually controlled by the database architecture itself. So the next step was then populating the geodatabase with all of the wonderful products that Katie and Matthias and Loderai, had generated. And we also wanted to sort of preserve the data that was in the existing Inlets Atlas. So in this process, we're also migrating data from that existing Inlets Atlas into this Inlet Atlas 2.0. So on the map here, we're just kind of showing a very similar view that you've been seeing now of those inlet locations. They're just symbolized or colored by the district in which they lie. And there's about 5 inlets that are sort of highlighted in kind of a cyan color. So with those inlets, we just run an append operation on the project reference point feature class, as well as its associated point info table, and then use the field mappings to sort of crosswalk the attributes from like SDSFIE. So crosswalk the attributes from the existing Inlets Atlas into sort of the SDSFIE, nomenclature. And like this is just an example of a field map here. The sort of SDSFIE fields are kind of in the column on the left-hand portion of the screen, and then the existing Inlets Atlas were in the column on the right here. So it's just a matter of going up and going and matching up the attributes. After that's done, we calculate those primary and foreign keys, and then verify. Again, here just using a global ID field, and then verifying the relationship classes are actually working as they should be. There's a number of ways to do that. So here we're just looking at an ArcGIS Pro map with Oregon Inlet that's kind of selected or highlighted there in the project reference point table. And then over on the pop-up, as you sort of drill down the information, you can see that it's linked or associated with this project reference point info table and this Oregon Inlet record here, and then see all the different attribute fields or metadata that we're storing for that particular inlet location. So the raster, populating the raster data products is a little bit different. The first thing that we actually did was load those raster products into the geodatabase itself. Once they were loaded with a batch copy raster tool, once they were loaded into the geodatabase, we then built and configured a mosaic data set, which you kind of see here in the map there, kind of with all those green boxes, and that's just the bathymetry mosaic data set. If you don't have familiarity with mosaic data sets, it's just it's basically like a time stack in our kind of vernacular, it would be like a time stack of data, say in a given, location or even across different locations. And it doesn't, and it actually, it stores, it's more of a link to like data, on disk, or in this case, in the geo database. And it can mosaic that information just on the fly, so that you're not having to run manual sort of data set mosaicing operations. So similar, with this, we then will copy those mosaic dataset footprints into our raster footprint, official raster footprint feature class, as well as transfer the attributes to the associated raster footprint info table. And like the vector data, calculate those primary and foreign keys and other attributes that we want to share, and then kind of verify the relationships between all of these data sets. So here in the map in green, you see that raster footprints feature class. You see that it is associated with 1, 2, 3, 4 different sort of data sets in time. And then if you drill into any one of those data sets, you can see, so in 2018, for example, with that 2018 data set, we see that available. We have a bathymetry product and a relative relief product available. And then the various information associated with each of those. And then, so that's sort of the ArcGIS, online kind of, how we initialized the geodatabase and populated it with the data that the team, is generating. And so that's just sort of one means of, access of all of these information if you have sort of that, geodatabase connection. We also took an opportunity, as I had mentioned earlier, to put these data sets and share them as a spatiotemporal access catalog. So the first thing we did with that was to migrate these final products up to the CHL threads server there. We then developed a Python script to build a stack catalog locally, leveraging the URLs from the CHL threads server to the products themselves, and some thumbnails that we created. And then that script also specifies some collection and item metadata for the spatiotemporal access catalog. That was then also copied up to the CHL, threads server, and that's what we're kind of seeing here. That the screen captures just the sort of the landing page. That's the graphic in the furthest back. It's the landing page for that threads data server, the link to the Inlets Atlas, data, and then if you expand that, there's a product folder, and then there's that catalog, and it's that catalog that's effectively that spatiotemporal access catalog. And so you can see under that catalog, we have different collections for kind of the different product lines. So whether that's bathymetry, the geomorphons products, or the relative, relief products. And then within each of those, we have the different assets. So those are those actual, data products that are in that products folder. If you're tracking. The next thing we did was publish all of this information as web feature services. Again, this was all done in ArcGIS Pro with the ArcGIS Enterprise portal and server, with the support of Mike Fort and the CoreCam project. So in order to do this, we had to register our Enterprise Postgres geodatabase as a data store, and then it was as straightforward as building, our web map for how we want the service to look. So here on this web map, or this map, we're just we have like our inlet projects. So that's that project reference point layer. It's just renamed inlet projects here. We also have our inlet product footprints, and again, that's that raster footprints geodatabase layer that we've just renamed inlet product footprints, and then our sort of related tables for those two data sources. And so with this, we save it, we add the necessary metadata to describe the data layers in the service, and then we share it as a web layer. to the portal. And so for these vector data sets and tabular data sets, we share them as a map image, but we enable the feature access so you can access individual rows or columns in the data sets via the service itself. And this is also where we tell it what portal folder to put it in, and we set sort of our sharing level or who we want to be able to see this data, and then any groups that the item needs to be shared with as well. On the raster side, as I mentioned, we have mosaic data sets that are built for each kind of main, product line. So in these examples, they were talking about the bathymetry products, the relative relief products, and the geomorphons products primarily. And so similarly in ArcGIS Pro, we construct our web map with our sort of our product of interest for the service. So we do this for each of the primary products, a separate web map. So here we have the bathymetry products, and we're just sharing those as a web layer. What's different here is we are sharing these layers as just web map images. So there really isn't any kind of feature level information to provide there. And again, we sort of specify the folder that it should reside in the portal and set, our sharing information. And like the what we just saw before, the service has all the necessary, metadata to describe the data layers, and the service. And so for accessing all of this information, sort of I think a good first landing place would be the CHL GIS portal. This is that ArcGIS Enterprise 11.3 portal. It's really a portal for content management for all of the various feature layers, web maps, and apps like custom dashboards or web experiences. So once you land there, you could then discover a group called the CIRP Inlets Atlas 2.0, which is in the middle of the group. So we've used this group to kind of organize all of the content related to this work unit. So there's just a very brief description of what the group is or has, and then you can see the different items or content that's been created and shared in that group. And so if any one of those items sparks your interest, you can then open them up like this CIRP Inlets Atlas 2.0 web map. This is called the portal item. And so you can see all the item information, and you can just go right ahead and open it in a map viewer if you're so inclined. But I also like to point out that on these item web pages, which is seen on the graphic on the far left-hand side, it also has direct links to the actual web feature layers that we have shared. So you can learn more about the layer through that layers item page, but probably most importantly, there's this link to a URL on the bottom, and that's a link to the actual feature service for that particular data layer. So in this case, it would be those inlet project points and product footprints in the various tables. And so this is a service URL you can use in ArcGIS Pro, just saying add layer from URL, and or you could access the data through this URL programmatically in something like Python. There's a number of libraries that can support doing that. And then finally, the big kind of map graphic is just an example of what that web map looks like, and demonstrating some of the capabilities that are offered by the web map. So the sort of table of contents where you can toggle layers on and off to your heart's content. You can kind of run pop-ups on there are pop-ups enabled on some of the layers, and with custom information that we're leveraging those relationship classes to link the data to. So if you selected a inlet project like Moriches, New York, the 2022 data, you can then see that there's like a bathymetry product and a relative relief product available for it. You can then click one of those products, see additional metadata on it, and then access that actual product itself. There's a download URL that you can use to sort of save that TIFF file to your local computer if you're so inclined. And then I did actually recently just update this morning, so that stack URL is populated as well if you're looking for that. And I literally just added this slide probably 5 minutes before the talk today, but we wanted to demonstrate the power of leveraging these relationship classes and globally unique IDs to enable interoperability with other data sets beyond the Coastal Inlets Atlas 2.0. So here is just a proof of concept demo where we have populated our geodatabase, our features with the various national channel frameworks, say reach that the feature is associated with. And so now we can use those national channel framework, foreign keys. That's the channel area IDFK and that channel reach IDFK with custom arcade language and an ARC map to link the inlet information table to the national channel framework information in a web map pop-up as shown here. So in the existing Inlets Atlas, this information, like the authorized depth or depth maintained, was more or less hand jammed into that ArcGIS online, database. And so now we don't even need to store that information anymore. We can just link to it because again, it's been stood up in an enterprise kind of fashion, that promotes and enables open, linked, and interoperable data. Accessing the stack here, we are wrapping up. That's the link to the actual, stack catalog. You can access that directly in ArcGIS Pro under that sort of insert menu. And that's kind of where the screenshots that you're seeing here came from. So this is what that might look like. And then there are also different Python libraries for programmatic access of data in stack catalogs, PyStack kind of, I think, being a popular one, and there's a few others as well. And so having done this now, I think there's a number of next steps. First and foremost, this is really the first time we've shared this information on the Inlet Atlas 2.0 and its architecture and how we've sort of stood things up. And so I think this work unit would greatly benefit from some feedback on these products and services from our PDT members, our CIRP geospatial products team members and others, either in the field, or researchers, and really it's the feedback. Any feedback, good, bad, and ugly, related to ease and access of use or the interpretability of these data products and services, the documentation, and then finally that sufficiency of the attribution and ideas for expansion. Like if you were wanting to answer a question with the data in this geodatabase, like what kind of attribution would you need to be able to answer that question, and like do we have it or do we need to try to add it? I also wanted to highlight that Dr. McFerrin and others have submitted a paper to Scientific Data that describes and documents these data products that they have developed. And with that, they've also compiled the products into a database that they're sharing via Zenodo. So that's just yet another means of access for these products once that paper comes out. And then we'd like to kind of complete the ingestion of the products into the Inlet Atlas 2.0. So we've largely been focusing on some of the products from the raster analysis. So we do not yet have those chronostratigraphy products or those conformal mapping products integrated in the geodatabase yet. And then furthermore, Katie had mentioned about 13, inlets now that have been analyzed. So we would sort of like to complete the population of those inlets in the geodatabase. But I'm hopeful for some feedback before we do that. And then if there is some magical pot of funding that comes our way, we'd love to take the opportunity to sort of expand kind of the web look and feel of the Inlets Atlas, sort of beyond this very simple, web map into a full-fledged web experience. Largely, probably do that with contract support. And then we could always further automate our workflows just to ingest the products and do all of our field calculations, et cetera, to make things a little bit more efficient. And then I've been thinking a lot about the provisioning of the raster products. Right now, they're served largely as map image layers, which certainly promotes sort of the discovery, and access of those, data products. But they're not a full-fledged image service. So one of the big differences there is, in the web map, you're not going to be able to zoom in on a geomorphon's product and click your mouse and see what that actual pixel value is in the raster. You can't do that with a map image layer, but you can do that with an image service. And so that's just something we're considering, again, with a magical pot of money. Katie shared a number of references that have been resourced as this work unit has proceeded. So they are here for your review. And with that, we're happy to take any questions. We certainly appreciate your time and participation today.